Hello everybody. So I thought I'd go on a little bit of a diatribe now about my mathematical education and my attempt now as a 27/28-year-old, I'm 28 now, my experience is trying to learn mathematics as an adult. So this is something that's proved to be very, very hard indeed for me, and it wasn't hard for me at school. However, what I did at school mistakenly was slough off my mathematical education to some extent, because I don't know really why. The thing about mathematics at school is if you miss any steps in your education, it all sort of starts crumbling to pieces. And I don't know when the exact point was that I started to do this. It may have been with surds, I think. And I think to a lot of people who are sophisticated mathematicians or educated mathematicians, they'll think about surds as being something pitifully easy and simple. But for whatever reason it foxed me back then, or it was boring back then and I didn't learn it. So yeah, I think there's a deep problem with mathematical education. I'm not 100% certain what that is, but I think it amounts to something like not encountering more advanced topics earlier, and I'll get into perhaps more detail on that later on in the video. But for now, I've been attempting to learn the maths in this A-level maths textbook, and it is absolutely foxing me. And I got to see it GCSE, so it's not such a huge surprise that it would fox me. But what I'm finding more now is to, for instance, factorise expressions, I have to go back and review factorising from GCSE or GCSE level by watching YouTube videos about it. I'm just thinking, like, it's dispiriting. It really, really is, because I want to do physics at university level in about a year's time or so. So I need to get this stuff really, really sorted in my mind, in my brain. I need to rewire my brain, as Neil deGrasse Tyson says, to the understanding of mathematical concepts and mathematical intuitions, let's say, or how to glean mathematical intuitions from mathematical concepts. So yeah, very troubling for me. And but then again, I've tried to do this numerous times over the years, and I've gotten somewhere with actually quite a lot of it on Khan Academy, for instance. I found to be an excellent resource. I managed to get sort of trigonometry down to some extent, and actually trigonometry is something I found really hard at GCSE, and something it made me give up on the whole thing. And yeah, trigonometry very difficult, but I managed integrals quite well, or some simple integrals, and I found actually differentiation not as hard as I thought it would be. So I think when it comes to this, I think part of the problem is that we don't encounter things like integral and differential calculus earlier on, since if I were taught these things, I think that I would have a far better grasp of mathematics now than I do. And I think there's certain things in maths, in the more advanced topics, that I find very, very intuitive and really not as hard or easier really than I thought they would be. And integrals and differentials are one of them, I think. Whereas trigonometry just messes with my brain. And surds just were boring for whatever reason. I don't even know what a surd is now. And I just watched this thing about factorising algebraic expressions, and yeah, that did come back to me also. And I don't think with this stuff there's any special level of intelligence that you need. I think anyone could probably learn it if they just put in the time to learning it. It's just, yeah, finding that time and figuring out the heuristics behind the thinking and figuring out how to learn it properly. So, well, that just takes time. So it's an interesting journey, and I'll probably keep people updated with how I do in my physics course when I get on that eventually. So I'm going to do physics and philosophy with the Open University. after having for many years tried to be a humanities student and specifically an English literature student, and just really getting dispirited with that subject and finding it a total pain in the arse to have to read books that I don't really want to read and what have you, but still loving philosophy and still wanting to pursue philosophy, and then also at the same time having all these amorphous or not so amorphous ideas about quantum gravity and things like this, and reading a hell of a lot of physics texts and physics papers and physics Wikipedia articles, albeit, and yeah, thinking that I'm right about quantum gravity and really wanting to pursue that idea. So I think I'm going to still go for it. I just need to do a lot more Khan Academy, a lot more maths learning from the books, and then I will hopefully pursue it properly more. Maybe I'll try to hypnotise myself into being good at maths by just flicking through it and doing like a Darren Brown. Breathing the cool air of the maths book. Wonderful. But anyway, yeah, so that's where I'm at. I'm at factorising algebraic expressions, and I'm nowhere near good enough at it. But I know within this I'm going to find stuff that does make more sense to me and will be easier. Like matrices. I found matrices oddly simple and easy. Or simpler and easier than I thought they would be. But if I were to look at one now, it's probably gone out of my head and I wouldn't know what it is. So, I don't know, it's really, really tricky. Maths is tricky, tricky, tricky maths. So what is this? Find the mean and sum x squared equals thing over x with a hat on it, x squared over n. It was 300 over 12 equals 25. X squared equals 8,150. Oh, the standard deviation of the following data. Okay. Okay. Did I find that stuff easier, standard deviations and so on, when I was at GCSE? I'm not so certain I didn't, actually. Vectors. How to get from point A to point B to point C. Interesting. Because I have a huge love of and respect for maths. I didn't at GCSE though, so I stopped doing my work. And like that, like nothing else, will scupper your mathematical ambitions if you do that. If you just slough off work and be like, meh, maths. And then come back many years later with ambitions of being a mathematician or physicist. And be like, well, you needed the maths, didn't you? And it's like, yes, I did. Yeah, so I deeply regret not paying more attention to that part of my education, and I deeply regret now having to use the small amounts of spare time I have working on a farm to learn mathematics. But then again, it is a great pleasure learning this stuff and getting to grips with it, and for things to become easier as you learn them, and for the more advanced topic concepts to open up for you as you get deeper into them, and it's not so terrible once you get into it properly, I think. So thank you everyone for watching. That's been my little screed about maths learning. Oh yeah, and I was going to say about how to improve mathematical education by getting into topics such as calculus earlier on. I think a lot of calculus actually could be taught at primary school, and this is the real problem with it, because they're thinking, oh, calculus, oh, it's such a grand and difficult subject, it must be so impossible for anyone to be able to grasp. I think it can be taught to young children, and I think it should be taught to young children, because I think it's really the sorts of things in, yeah, simple calculus, and it's getting those sorts of concepts in place early on, like the chain rule and the power rule and things like this, that really would make more advanced topics in mathematics very easy to understand. And I think of figures like Terence Tao, and you think, well, where did Terence Tao's brilliance come from? And then you look at his parents. What did they do? His mother was an astrophysicist. His father's a doctor. So, from the cradle, he would have had exposure to very, very advanced topics in maths. And both of his brothers are the same. Brothers, or does he have brothers, I think. And both of them were mathematicians at an international level, I think. Were they not? They were both mathletes. And it just so happened that Terence Tao went on to become the greatest mathematician living. So, I don't think, again, there's anything supernatural necessarily about people's abilities when it comes to this sort of thing. I think it depends largely on how much exposure you've had, how early on. It's nurture rather than nature, I think. Particularly when it comes to something like mathematics. And, he would have had exposure to all the advanced topics at a very early age, as would his brothers, and they went on to become great mathematicians. All of them, but one of them was the greatest mathematician, it happened. So, I think, and there's also a way of gaining physical intuition for things, gaining intuition for physical systems. A lot of people have this, I suspect, but not an awful lot of people would necessarily be able to mathematise them and to put them into mathematical form and to figure out the written language, if you like, of physical systems, except in a fleeting way such as I've been able to over the years, I think. And gaining that is tricky, is a little difficult. However, if you were to start teaching more things like mathematical physics or physics, at primary school, because I wasn't taught physics at primary school at all. We were taught all things like geography and history and French even, a tiny bit of biology and maths, but no hard science. Well, no biology even. I don't think. I don't remember. But we were taught maths, some maths, some probability theory, I think. A little bit of algebra here, there, and everywhere, but no calculus. And I think calculus can be taught earlier on. And I think a hell of a lot of this stuff can be taught very early on, and really ought to be. But that teaching would be more effective if it were paired, I think, with a teaching of physics and chemistry and biology. In their, maybe not in their mathematical senses when it comes to chemistry and biology, but teaching physics at primary school, certainly, I think is a very, very good idea. And the hard sciences at primary school. And I don't know whether or not that goes on now, but when I was at primary school it certainly didn't. Or it wasn't done at my primary school anyway, and that is something which I think is a bit of a shame, and it robs a hell of a lot of students, I think, who could have a lot of potential within those fields of that potential, and replaces it with things like art and drama and music, which I think they're all very well and good, but I think they're more for your spare time than they are for your education. So, oh, and of course we're taught English at primary school, aren't we? Taught all about children's books, by the way. We learned I Am David, which is a children's book about the Holocaust. It's about the Holocaust, so it's literary, but it's a children's book nonetheless. Where was the physics? There was none of it. You could teach the simple shit, F equals ma. But we didn't encounter an equation in physics until we were 15. So, what fucking... We didn't stand a chance, did we? And I wasn't in the top set for physics. I was in the second to top set. So, it's like... Did all the top set kids get all the maths and stuff in the physics? And they were told why the maths was important and what all the maths means and so on. Yeah, I wasn't, because I was in set 2. Huh? Fucking school. And then also, I was in set 2 for maths, and then I got bumped down to set 3 eventually, when I started fucking off maths. And they put me down to an intermediate GCSE in maths, because they thought I wouldn't be able to handle the higher topics and make the school look bad or something if they put me in for standard maths GCSE. So the maximum grade I could have gotten was a B. I ended up with a C. And I thought, no, well, maths isn't my thing. I won't pursue it. So I think we've got like this idea that we need to pander to children in education. No, we need to shut up and learn. That's the thing about it. And yet encounter difficult stuff early on. And it's like, we need to make learning entertaining and so on and so forth. And like, yeah, it can still be entertaining and enriching and fulfilling if you teach them a bit of integration. Or teach them a bit of factorization. Why not? Because, you know, they won't all get it, but some of them will. Yeah. And then some of them won't get factorization, but they'll become really good at integrals. It's like anything, it's like any subject. You know, there's some people some geographers probably don't understand soil composition all that well, but they're really good when it comes to urban development and that stuff. Or even within physical geography, they're probably really good at longshore drift, you know? I used to love a bit of longshore drift in geography. That was one of my favourite things. Longshore drift. Brilliant. Love it. Anyway, that's been my little diatribe about mathematical education. Thank you very much for watching. I love you lots. And please wish me luck in the future of my mathematical education now as an adult, as a 28-year-old, because I will fucking need it. So thanks everyone for watching. Bye bye bye.